Hey, how's it going, Laguna? It's Mr. English, and today's lesson is on chemical reactions can be written as chemical equations. First, we're going to review from yesterday. And so we talked about chemical reactions yesterday, and there are tons of varieties of chemical reactions in the world out there, and many are taking place inside of us right now. But a chemical reaction is any change in matter that produces one or more new substances. They occur when bonds between atoms in a molecule break, and new bonds form between these and other atoms, forming new substances. Certain molecules react with other molecules and some don't. The substances that begin the chemical reaction are called the reactants, and the new substances created by a chemical reaction are called the products. We'll be taking notes on page C13 in your science notebook, and you can title the page Chemical Reactions. You only need to write what is written in black font. Here's what your page C13 will look like, and again, you only need to write what's in black font. You can title the page Chemical Reactions. Chemical reactions, so you'll title the page Chemical Reactions, and this will be the first sentence. Chemical reactions involve changes in properties and changes in energy that you can observe. Examples include a change in color, texture, or hardness, energy being released, energy being absorbed, smoke, gas being produced, or the formation of a precipitate. When we did the seawater investigation lab as part of the sedimentary rock unit, we introduced carbon dioxide gas into a liquid and formed a precipitate, but you can also have two liquids mixed together and form a solid, and that would be another example of precipitate. Anytime you have cloudy liquid, there's a pretty good indicator something chemically reactive is going on. And as scientists, to describe what happens to all of the atoms and molecules in a chemical reaction, we use chemical equations. And because it's important to write them correctly, we're going to spend today's lesson learning what the symbols in a chemical equation mean. And chemical equations are a shorthand way to show what happens to all of the atoms involved in any chemical reaction. You're going to add this new definition to page C2 and C3 in your words of chemistry as well. And lastly, in a chemical reaction, atoms are neither created nor destroyed, only rearranged, and this is the law of conservation of mass. So, thirsty for some carbonic acid? Try this chemical equation. You've probably had sparkling water before, and if you've ever used the SodaStream machine, I'm out of carbon dioxide gases in order to add carbon dioxide to my bottle of water, but essentially all you're doing is adding CO2 to H2O to make sparkling water. You've probably had sparkling water before, but for those of you that were in my classes, we talked about carbonic acid quite a bit as being one of the components that will chemically weather rock outside. And so did you know that carbonic acid acid rain is also what makes our sparkling beverages sparkle or carbonated? And it's a very simple chemical reaction with your reactants on this side. CO2 reacts with H2O to yield H2CO3, carbonic acid. And moving on to the next slide. This is the chemical equation for the demonstration that I did in yesterday's video with vinegar and baking soda. So vinegar and baking soda is the household products that we used in our chemical reaction. And here is the chemical name for vinegar. It's acetic acid. Reacts with is what this plus symbol stands for. And the other symbol that's going to be new is the arrow, and that means that it yields. And here were our products. We had sodium acetate, which the common name or chemical name, if I were to write that out, is hot ice. I'm not going to. Reacts with water and carbon dioxide. So these are our products. And here is the chemical formula for the molecule of acetic acid. And here's the chemical formula for the molecule of baking soda, or sodium bicarbonate. Here is the chemical formula for sodium acetate. Here's the chemical formula for water and carbon dioxide. As you become more familiar with the elements, whenever you see the word sodium, you can anticipate that when you see the chemical formula for the molecule that sodium is in, you'll recognize, well, hey, it has a Na in it, so it's probably going to have sodium in it. Or capital C, oh, it must have some carbon in it. So now you're going to copy down this reaction, and I'm going to ask you to be very careful in your writing so that way you have all of the subscript numbers written correctly. And so on page C13, you're going to copy this down under your notes. It says acid and base chemical reaction. Vinegar reacts with baking soda to yield sodium acetate and water and carbon dioxide. C2H4O2 reacts with NaHCO3 to yield NaC2H3O2 and H2O and CO2. This next concept that I'm going to introduce is called a coefficient. So a coefficient tells us how many of each molecule is present in the reaction. If no coefficient is in front of the chemical formula for that molecule, then there is only one of that molecule. In this reaction, there are no coefficients because for every molecule of vinegar and baking soda you have, you're going to yield one molecule of sodium acetate, one molecule of water, and one molecule of carbon dioxide. But some chemical reactions aren't like that. For example, in order to make molecules of water, you actually need 2 molecules of hydrogen gas plus 1 molecule of oxygen gas to yield 2 molecules of H2O. And I'm going to go to a simulator to show you more examples of that and make it more visually pleasing. I'm going to pause the video for just a moment, but you won't notice anything. And then I'll open up the simulator. Here's what your page C13 should look like when it is complete with that chemical reaction down below and the definition for coefficients. All right, so this is the simulation I mentioned, and I'll leave the link to this website in my Google Classroom post. But you have 3 options when you come to the home screen, and there's sandwiches, molecules, or game. And we're going to work with molecules. And the chemical formula is up here at the top. And right now, as you can see by this little button that's marked, we are making water. So the chemical formula to make water has a coefficient in it because you need 2 molecules of hydrogen gas to react with 1 molecule of oxygen gas, which yields 2 molecules of water, of H2O. And what does that mean? We will look at the little simulation to help you understand that. And so before the reaction, if you add 1 molecule of hydrogen gas, there's actually 2 hydrogen atoms here, right? For every H2, you have 2 atoms of the element hydrogen. But the coefficient is a multiplier, just like the distributive property in math. That 2 is going to be multiplied against every atom within this molecule. So thankfully, the chemical formula for hydrogen gas is pretty simple. It's 2 atoms of hydrogen bond together with a molecular bond, and they represent 1 molecule of hydrogen gas. There's 2 hydrogen atoms. But the coefficient means that we have 2 of those molecules, which means that we have 2 times 2 for 4 atoms total. And you can see this down in the simulator here. When I click on the up button, it adds another molecule of hydrogen gas. So we have a total of 4 hydrogen atoms plus, or reacts with, 1 oxygen gas molecule, which is 2 atoms of the element oxygen, to yield 2 water molecules. And they look like this. Okay, so for every 2 molecules of hydrogen gas plus 1 molecule of oxygen gas, you get 2 molecules of water. Now, what happens if I don't have enough hydrogen gas? Let's say I only have 1 molecule of hydrogen gas and 1 molecule of oxygen gas. Well, there's no reaction that takes place. And so as a chemist, we would write no reaction. And these are our leftover products, is that there's, a couple atoms of oxygen and a couple atoms of hydrogen and a couple atoms of oxygen. Let's do another example. And again, using the coefficient, it's the full-size font number in front of your molecule. And usually you wouldn't write a number 1 here in front of the oxygen gas, but I think because the simulation is pretty basic, they wanted to show that there's only one molecule of oxygen here, and they've actually used the number, but usually you wouldn't actually write that number there. So let's make ammonia. So ammonia, the chemical equation for ammonia is that 1 molecule of nitrogen gas plus 3 molecules of hydrogen gas result in 2 molecules of NH3. And NH3 is the chemical formula for ammonia. And ammonia is a colorless gas with a very pungent smell that is used in household cleaners like Windex or bathroom cleaners. So what they're telling me is that for every 1 molecule of nitrogen gas, I need 3 molecules of hydrogen gas to yield 2 molecules of ammonia. So I will go ahead and I'm just looking up here at the 1N2. So I need 1 of those plus 3 of these. And when I do that, it yields 2 molecules of ammonia, NH3. Without the correct number of reactants, I won't get the product. All right, and the last one would be you can combust methane, which is natural gas. And so in the classroom, we would be doing this with the Bunsen burners, but you can see that this is what the molecule would look like. And this is what the oxygen gas molecule would look like. And I'm going to have a question for you to answer like this in the Google form for today.